Alright guys, so here we are. We're going to be looking at the next batch of work that's been posted. We're going to be buzzing down the assignments one at a time, and these videos will feature explanations of what's going on, how to do it, and it'll show us doing some examples from Delta Math. So the first one up I'm doing is the first assignment on the list, express in simplest radical form. You guys may not remember, but this over here is called a radical. It is how you do a root, a square root, a cube root. This is the idea. And it's basically like if I were to say the square root of 9, that's basically asking me what number was squared to equal 9. And I have to look at that and go, oh, well, 3 squared equals 9 because 3 times 3 is 9. That's the idea of a radical. Sometimes, though, we don't always have perfect radicals. We might have, for example, the square root of 12. Here we have two options. If you have a calculator, you grab your calculator, you hit the square root button, and you type in 12, you hit enter. You're going to get something in the neighborhood of, I don't know, 3.4, 3.5, something like that. But if you don't have a calculator and you can't just guess these in your head, what you want to do is simply break it down. I want to think about what things could make parts of 12. For example, I can say the square root of 4 times 3. If you think about it, 4 times 3, this part right here, will make 12. And I can then break this down a little further. I can simplify it more. We're simplifying kind of like fractions. Because we are allowed to take this bit and do this. Make it the square root of 4 times the square root of 3. And a lot of people skip this step. And, well, square root of 4 we can totally do. What number was squared to make 4? Oh, that's 2. And what number was squared to make the square root of 3? I don't know. So we're just going to leave that as 3. So in the end, we would write 2 with a radical. So 2 radical 3, or 2 root 3 is how it's frequently said. That's it. I've simplified it. If it was something like 9 up top, my answer would have been, oh, 3, done. Down here where it gets more complicated, I'm breaking it down some. So I like to just go through and check these for pretty common numbers. So if we direct our attention to the one on the left, that's from Delta Math. Wow, Delta Math. Square root of 45. You guys can pause for a minute if you want. It's not a perfect square. Like, you can count by the perfect squares if you want. Like, 5 squared is 25, 6 squared is 36, 36 smaller than 45. 7 squared, 49. Okay, this is something between 6 and 7. It's a decimal. I don't know. What I do is I just start breaking this down then. It's what's called an imperfect square. It's irrational. I want to simplify it as much as possible because that's my directions. Express in simplest radical form. So I go, okay, could I do 4 times something to make 45? Well, 4 times 11 is 44, not good enough. And 4 is 2 squared. That's where my 4 came from. So I go, okay, that's why I was thinking about 4. It's 2 squared. And I go, okay, well, what about 3 squared, or 9? So I'm going to go, does 45 divide by 9? Well, yeah, it does. I'm going to get the square root of 9 times 5. Now, real quick, guys, you can go, okay, square root of 9 times the square root of 5, and then get that you'd have a 3. A lot of people simply skip this part, and they'll just go straight down to the bottom. But root 5 is nothing. There's no number squared that makes 5. So 3 root 5. In Delta Math, I'd go to type in my answer. I'd hit 3. There's this nice little square root button. I press it. I hit 5. I hit submit answer. And are you sure you want to submit this answer? Yes. I got it right. Like they're even showing you right here, they're doing the same thing I did. 45 divided by 36, that's a decimal. 45 divided by 25, that's 1.8. 36, 6 squared, 25, 5 squared. Keep going. You see right down here, they got the 9. Now me, personally, I like starting from the small numbers and working up. That could lead you to a trap sometimes, because you could have something that, for example, if we had 64. 64 could divide by both 4 and divide by 8. So it gets a bit dodgy. So you want to be mindful. I'm going to pause temporarily. So again, what we're trying to do is simply find some perfect square that can divide these problems and move on with it. So new problem, 32. I'm going to go down my list, I'm going to use the perfect square part. So I'm going to divide by 4. Does 32 divide by 4? Short answer, yes. So I go, okay, 30, or sorry, let's just get rid of this junk. So does root 32, okay. So I can make it 4 times 8. But here's the thing, when I look at 8, you shouldn't be going, oh good, I'm done, because I could divide 8 a little more, honestly. And I could go, all right, so I should have 4 times, and then I could say 8 divides to be 4 times 2. If you ever see 2 of the same number, you really know it's that number, because 4 times 4 is the same as 4 squared. So it gets a little murky. This is why some people start with larger numbers and work backwards. Because, you might be tempted to stop and go, oh, 4 times 8, and try to say the answer was, okay, 4 is going to be 2, and then I have root 8. You might be tempted to stop there. Your answer would be wrong because it's not simplest. It's kind of like if you said, oh, I have 4/8, and then you simplified 4/8 to 2/4. Well, 2 over 4 can simplify to 1/2. You're not done if you go here. You're not wrong, but you're not done. So this is why some people like to start with bigger numbers and work back. So if we had, for example, written down 4 squared equals 16, or you knew that, and I started just, 5 squared equals 25, and 6 squared equals 36. So I'd start at 5 because 25 is smaller than or equal to 32. 36 is bigger than 32, so I can't divide 32 by 36. I could go, does 32 divide by 25? No. Does it divide by 16? Yes. And I could have instead had 16 times 2, which we would then find out is 4 root 2. Down here we could have kept going with that. But this is why some people like to start with larger numbers. So in this case, I would find that the answer was 4 root 2, and it's no big deal. I go over, boom, 4, square root 2, submit answer, yes, done. But one other way you can find a source for these things. We all know way back in the day when we did multiplication tables. Random one I found in Google image. What you're looking at here is a standard 1 to 12 multiplication table. If you look, all the squares that are green are perfect squares, like 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. I'm essentially using these perfect squares all the way down. So here I go, okay, new problem, 28. From what I was just doing a minute ago, I don't want to bother starting at 36 again because 36 is bigger than 28. So boom, 25. Can I divide 28 by 25? Nope. Can I divide 28 by 16? No. Can I divide 28 by 9? Nope, but I'm getting closer. Can I divide 28 by 4? Yes. So my root 28, I would divide it by 4, and I'd go, okay, that's the square root of 4 times 7. All right. 4 we know will become the 2. And the 7, well, there's nothing to really take for that, so it's a square root of 7. That's it. Done. It's the same thing over and over. This shouldn't represent a challenge, especially if you take the time to find, like I did for the example here, a multiplication table, and you just go, okay, what number is this smaller than? Okay, so like if I gave you, for example, the square root of 72. Well, you could go, okay, square root 72, smaller than 81. So you'd start checking, divide it until you got down to, oh, hey, that's 36 times 2. So you'd go, it's 6 root 2. These things can be done. It's not a big deal. Again, if you have questions, see your math teacher during tutoring. For those of you that have Mr. Tibbetts, feel free to contact Mr. Tibbetts. And for my guys, you know my Google Voice number, you know my email, you know when my office hours are. It will again be posted in the post. Read it, make sure you watch the videos, come with questions. Be well.